Alright, I'm going to make a little video to help you out with completing that 5-2 GIZMO deal, because that was kind of a brain buster, and then we had a little trouble with the technology in the class. So the first thing when you're doing that gizmo is you were supposed to, and I missed this when I was helping a few folks, you're supposed to set it, to k equals 1. So if you do that, the slope is k, but you can tell if you look at what the slope is after you plug the 1 in there, the slope should be 1 if you can tell how much you go up and over. Now ideally I would have the gizmo up as well showing you that, and I did, but then I was having some troubles with it. It has some error, so no worries. We'll just work here and with the scratch pad. What's the y-intercept? Well, when you looked at the graph, you should have seen that the y-intercept was right at 0. So it was 0. Okay. Always it was, all your lines that you kept drawing, they kept going right through 0. Use the slider to vary the value of k. What changes in the graph of the line? Well, hopefully when you change the k, you should have kept noticing that the slopes were just going like this all over, left and right, up and down. But it was still going through 0, 0. So what stays the same? What changes is the slope, and what stays the same is the y-intercept, the fact that it goes through 0, 0. How does the value of k relate to the slope of the line? Well, they are exactly the same. Okay, so the k is the slope, so exactly the same. All right, so then part 2 is saying, now what we want you to do is we want you to set the k equal to 4. So you go ahead and do that. And then also, when you go to that gizmo, you have a spot where you can go to the table and you can kind of change the table values. You have to kind of type them in. And when you type them in, you should be able to plug in a 0 for the x min, and then put in a 10. And then there's a spot to see how much the steps you go up by 1 every time you type that in. Then the y column shows how the y's change every time you plug in a different x. You can see what the y is. It's just a nice little table to show you that. So the first question, find the value of y when you know that x equals 3. So if you have that all set up correctly, if you look at the 3, it should say 12 for the y coordinate. Part B, how much does the value of y change from 3 to 4? And so if you did that on the gizmo, you should have noticed that it would go from 12 to 16. And then when you look at 6 to 7 on the table, it should have gone from 24 to 28. And when x changes by 1 unit like that, so 3 to 4, 6 to 7, how much do the y values change? So when x changes by 1, the y changes by 4. How does this relate to the constant of variation? Well, it relates because whatever the constant of variation is, that means that the y is going to be that much bigger than the x. So if I plug in any particular number here for x, then we know that the y value is going to be 4 times as big. So whenever we plug in something for x, we multiply it by 4, and that's why the y values, if you look at the table, they're always 4 times as big as whatever the x is. Back to this one, if x is 3, looks like the y is 12, which is 4 times as big. If x is 4, then the y is 16, again, 4 times as big. This one was 6, and it went to 24, 4 times as big. You get the picture. Now, divide each y value in the table by the corresponding x value. So if you took, for example, one of those y values like 16, and then you divided it by the x, you should get 4. And that's what you're going to get every single time when you take the y values and you divide them by the x's. Why is that? That's because what you're doing basically is you're taking the y's and you're dividing by the x's. So that means you divide by x on both sides, and you are isolating, you're basically isolating the k, because that's what k equals. K equals y divided by x. So let me start with a generic, y equals kx. If I divide both sides by x, then that's what k equals. So y divided by x. So it was having you take those y values in the table and divide them by x, and every single time we were getting 4, which for this problem, the k was 4. All right. On a piece of paper, go ahead and make a table of values. So what you would do is you would, maybe on that paper, even on the back, I think it was blank on the back, you would have a XY table, and it says, go ahead and put k equals 2.5. So that means you'd have 2.5x. That's your equation. Then it says plug in some values, like 0 to 10, gives an example. And let's see, what does it say? It says, see what you get when you plug them in. Do it by hand and see what you get when you plug them into the gizmo to see if it's the same. So plug in a 1, you should get 2.5 times 1, so 2.5. When you plug in a 2, you're taking 2 times 2.5, which it should be 5, and then et cetera, et cetera. You should have a data table here of all the values in the gizmo you should use to check. All right. Back to this. Let's see, next part. Every time you plug in a 0, you should get 0. So which point on the coordinate plane would always be part of this? So the coordinate, or the answer that would always be part of the equation, is always 0, 0. All right. Moving on to the problems that we could solve. So if an object's traveling, yada yada, constant rate, we're going to look at problem number 1. It says if a car travels 12 miles in 20 minutes, what's the value of k? And they're telling us that, let me scroll up a little bit. They're telling us what the x and the y are. They're saying that y is the distance traveled and x is the time. So we start off with our little equation. We have y equals kx, and we plug in what they give us. So they tell us 12 miles, and that, again, that's distance. So we plug in 12 for the left, and then we don't know the k. And the x, they tell us, is the minutes, so that's 20 minutes. So for this one, we put in 20, and that's minutes. And then we solve for k. So we got 12 miles over 20 minutes. And so k equals, we could reduce that, I guess. We could say, I think I'm going to kind of reduce it with a decimal. So I'm going to divide those with the calculator, and I'm going to say 0.6 miles, and it's per minute. Those are the units. Okay. So let's see what we've got next. What units? Miles per minute. That's the unit. Those are the units. On the graph, set k equal to the value, so try that with the gizmo. What's the y coordinate when you know that x is 20? Well, if we have our equation set up now that we know that k is 0.6, so we have y equals 0.6x. What would happen if we let x equal 20? We already know what should happen. When we put in 20, we should get 12, because that was the original information. 20 and 12 go together. So if we put a 20 right here, then we should get 12, which is what we would get. Let's see. Use the graph, part C. Use the graph to determine how far the car will travel in 125 minutes. Okay. So we could probably use the gizmo for that, but we could do it algebraically as well. So what we would do is we would take 125 minutes, that's the x. So we would take 125 minutes, and we just put it in here for the x, and that should give us the y, which is how far we would travel. So 125 times 0.6, that's 75 miles. All right, so there's the car one. All right, the next one, the computer printer. It prints 4 pages per minute. That's a rate. Anytime you see the rate, that's a slope, and that's going to end up being your k. So let's say y equals, it says that y is the pages, and x is the minutes. So y equals kx, and what's it say? Let's plug in our values. So we got, well, 4, again, is the rate. So that's going to be y equals 4x. That's your equation. In the GIZMO, create a function that models the printer's output. So in the GIZMO, you'd put your k equal to 4, and then you could use it to answer the question. How long will it take to print 15 pages? Well, the pages, again, is the y. So we put in 15 for the y, solve for x. So we got x equals 15 over 4. And again, x in this problem means minutes. So x minutes, we solve, we get 15 fourths, which is about, we could just divide it, and we get 3.7 minutes. 3.75 minutes, I should say. Okay? Let's think about that. It does 4 pages every single minute, and we're going to try to get it to do 15 pages, so makes sense. It could do, like 16 pages in 4 minutes, but we're asking it to do only 15 pages, so it's a tiny bit less. So 3.75 minutes. All right, that should help complete that.